Hi, my name is Markus Tatzgern, and I will present our work on the AirRes mask on behalf of all authors. The AirRes mask allows users to use breathing as natural input modality for virtual reality. In addition, the AirRes mask can adjust breathing resistance to provide a novel output modality. For instance, virtual experiences can utilize breathing resistance to provide perceptible feedback when users interact with virtual wind instruments. Breathing resistance can also be used to communicate the state of a user's virtual avatar, as it is influenced by simulated environmental conditions such as smoke and heat. We designed the AirRes mask with several design considerations in mind. We did not want to restrict the user's movements and at the same time wanted to robustly measure their inhalation and exhalation. Therefore, we did not use respiration belts, as these frequently suffer from motion artifacts during interaction. We utilize a medical-grade gas flow sensor that can precisely measure inhalation and exhalation of users. Here you can see an exploded view of the mask, consisting of readily available components and custom-designed 3D printed parts and control board. To allow for free and unrestricted movement, the whole breathing hardware is self-contained and wirelessly connects to the virtual reality device via Bluetooth. Breathing resistance must be adjusted in real time so that users perceive the effects of breathing into objects and so that the mask can quickly switch resistance during inhalation and exhalation phases. We realized breathing resistance by designing a rotating disc with a continuous opening that allows for continuous resistance adjustments. The disc is controlled by a fast servo motor. As the mask can restrict the airflow of users, we also implemented safety measures. The airflow is never fully blocked in the software. Furthermore, when the application loses the connection to the mask's control hardware, the resistance valve is opened fully. The same happens when the battery of the hardware is getting low. We also considered hygiene, which is highly important when it comes to respiratory interfaces. In short, airway paths of the mask can be replaced, sensor and mask could theoretically also be sterilized. We also made sure that the control electronics are separated from the airflow paths and can be reused. We performed a user study to explore the abilities of the AirRes mask. We implemented two scenarios. An escape room scenario, where users utilized their breathing for natural interactions with the scene and where breathing resistance was tied to these natural interactions. In a virtual firefighter obstacle course, breathing resistance was used to communicate the status of the virtual avatar stamina that was affected by running through the environment and by the stimulated environmental conditions heat and smoke. In escape room, users used breathing to solve simple tasks such as blowing out candles. We also included a task where users had to distinguish the weight of objects based on the required exhalation force in order to move these objects with their breath. This allowed us to determine if the AirRes mask was sufficiently precise to estimate weights of objects based on one's exhalation force. We included a similar task to investigate the ability of users to distinguish different levels of breathing resistance. Users had to blow up 3 balloons where each balloon exhibited a certain breathing resistance when exhaling. We compared natural breathing interaction against controlling the virtual avatar's breathing using precise joystick input. In the firefighter obstacle course, users had to virtually move through the environment and extinguish fires. The stamina decreased during running and by the heat and smoke of fires, which in turn increased breathing resistance. We compared the AirRes mask against a condition where the application provides only audiovisual feedback to communicate the virtual avatar's stamina, and a combination of both mask and audiovisual feedback. Audiovisual feedback consisted of a heartbeat that became increasingly louder and narrowing field of vision. For each participant, we measured successful task completion for the escape room and task completion time for the firefighter obstacle course. In addition, we asked participants to fill out questionnaires for presence, embodiment, physical effort, mental effort, and usability. After finishing a scenario in a condition, users had to perform a mandatory break in which we performed interviews to collect users' impressions. We also asked participants for the preferred condition in each scenario. In terms of preference, participants ranked the mask conditions higher than the other conditions. We only found a significant difference in spatial presence in the firefighter condition. This lack of significant differences could come from the fact that we used a different presence questionnaire than previous work. Also, 50% of participants noted that the servo motor was often audible, which could have had a detrimental effect on presence. Questionnaire results showed that embodiment was significantly improved over the joystick condition in the escape room, and the mask condition also led to higher embodiment compared to the feedback-only condition in the firefighter course. Physical effort was also significantly higher for the mask conditions. These results are in line with our expectations regarding the use of breathing interactions and breathing resistance. Overall, participants perceived breathing interactions as natural and intuitive, and they did not require extensive tutorials to solve tasks. The AirRes mask behaved as expected and allowed precise interaction. Users could easily distinguish between different weights of objects as they were blown through the scene, and users had no issues identifying different breathing resistances when blowing into objects. Overall, resistance added to the virtual experience. 58% of participants noted that the balloons were the highlight of the escape room, as the resistance was quickly switched between the user's inhalation and exhalation phases. In a firefighter scenario, participants clearly perceived breathing resistance as an effect of running and environmental conditions on the virtual avatar. Combining breathing resistance with additional feedback further enhanced the experience for participants. 33% of participants stated that the combination of breathing resistance and audiovisual feedback helped them build a stronger connection to the virtual avatar's stamina level. This strong connection to the virtual avatar has the potential to influence the user's behavior in virtual reality. It opens up applications to empathy research, training simulations enforcing the feeling of danger, or psychotherapy. The applications using the AirRes mask should allow users to adjust the parameters of the simulation to their own physiological characteristics. In our study, all participants used the same breathing resistance settings. However, 50% of participants stated that the resistance could be stronger. Breaks in realism were also noted by participants, where the simulation deviated from their expectations. For instance, one participant felt that the candles were too hard to blow out, while another one noted a delay when blowing into the wind instrument. One participant also noted that running would lead to a higher breathing frequency and not to a higher breathing resistance. This feedback indicates that virtual approximations of real-world tasks should be modeled carefully to fulfill users' expectations and to consider limitations of the technology. In terms of ergonomics, 58% of participants raised weight and comfort issues, which may have contributed to the significantly higher physical effort for the mask conditions. In summary, the AirRes mask provides a robust and precise way to measure breathing and utilize it for natural interaction in virtual reality. Breathing resistance as a novel output modality opens up the creation of novel virtual reality experiences, training simulations, and therapeutic applications. We provide the plans and software of the AirRes mask as open source to inspire future work utilizing precise breathing measurements as input modality, as well as real-time breathing resistance adjustments as output modality. Thank you for your attention.